Greetings and welcome to the video on the independent t-test. This will just serve as an introduction to the independent t-test. We'll work out a full example later on. And truth be told, it's probably easiest to kind of start with the independent t-test. So let me just go ahead and get a title up on the board here. So independent t-test. So there's 3 t-tests total in the family of t-tests. We're going to start with this one. We'll link it to design first. So kind of the way I've been showing this is if you had 10 individuals that were randomly selected and then randomly assigned into a group that got the treatment, and then you made an observation on them. You had another 10 folks that were randomly selected from the population, and they had been randomly assigned into this row, which did not get an X, which means it's the control group. They did not receive a treatment, and then you made an observation. This would be your design. And then an independent t-test means that this group here, group 1, is completely and totally independent of group 2. Okay? So an independent t-test is measuring mean scores. Remember, this O1 is going to kind of be an X bar of those 10 individuals. The O2 is going to be an X bar or mean of these 10 individuals. And those 2 groups are independent of one another, and we call this a parallel group design. So all 10 folks that are in the bottom never crossed over into the top row, which was getting the treatment. So these 2 groups are independent of each other, and that's what the independent t-test is going to measure for us. So what is then the equation? So let's just kind of look at the equation here. So to calculate the actual t equals the mean of group 1 minus the mean of group 2, all divided by this new term for us, which is the standard difference between the means. So let's kind of unpack this equation here just for a minute. Go to blue here real quick. So what does this numerator term mean? This is just a mean difference, right? You're just going to get a back that up just right here, there. Mean difference. You're getting a mean difference up here. And really, what this kind of might look like to you, if you remember kind of a z-score, what is a z-score? A z-score is kind of an x, a raw score, minus an x bar, minus a mean, divided by a standard deviation, right, for the group. And this form here looks kind of similar now, right? Except now we're taking a mean minus a mean. We're getting a mean difference. And on the bottom, instead of a single standard deviation, what this really is the standard deviation on this mean difference. And so to get this, what we can do is we pool the variances together, pool them. So this term actually breaks down into the following. So this term here is actually this square root of the variance of group 1 plus the variance of group 2. Well, how do you get this s squared sub p term? This stands for pooled variance. We have to introduce one more term here for us, which is the following. So what are we doing here? Let's unpack this last piece. So to get this pooled variance term here, right, we've got to take the actual calculated variance from the first group, group 1, so whatever this group represents here, and then we're going to weight that by this kind of fraction right here, which is going to be the degrees of freedom for group 1 divided by the degrees of freedom total. So in this particular case, we have this, right? So we know that the degrees of freedom for group 1, remember degrees of freedom are always n minus 1. And so in this particular case, you're going to be looking at 9, which is group 1's degrees of freedom, divided by the degrees of freedom total, which is 19, right? So you'd be weighting whatever this term is and multiplying it by this term right here. And then to that you would add the actual calculated variance from group 2 here, and then weighting it by its degrees of freedom divided by the degrees of freedom total. Now what you'll quickly see is these terms right here can really kind of drop out when you have equal groups. That means you have 10 in the top row and 10 in the bottom row. But you can still do this and pull them together and get a pooled variance when you have unequal n in each row. And so that's an important piece for us. So these terms right here would have to stay in for sure when you have unequal n. I always just tell students to leave them in, whether you have equal or unequal n. That way you never forget kind of the equation, you never forget that step, and so that's probably the best practice for you. Okay, so this is just kind of the introduction to t-tests in particular, and remember at the very end then, what are we going to be doing? We're basically going to say that, you know, if our calculated t, I'm going to put absolute value bars around it, so if whether or not it's we get a negative or a positive here, if our calculated t is greater than or equal to what our critical t is. Remember, our critical t was what we got out of that table where we had to look at some alpha, decide whether or not we were doing one or two-tailed, and then our degrees of freedom. If this statement right here holds true, then we're going to reject the null hypothesis. In other words, we're going to say, you know, our treatment had an effect. So that's kind of the big picture for the independent t-test in terms of the equation. So I would make sure that we are familiar with kind of what this particular equation here is doing for us. And then what we'll do is we'll have to still talk about the dependent t-test as well as the one sample t-test. So that's it for now. I hope you enjoyed the video.